Broadcast is now starting. All attendees are in listen-only mode.
Welcome to today's webinar entitled Designing Buildings for Maintainability. My name's Billy Zadig, Manager of Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA website later this afternoon. Please visit our website at www.apa.org to register for upcoming events and to view archived webinars for continuing education credits found under the Continuous Learning tab. APA U, Academy, and Institute will be in Fort Worth, Texas, January 9th through the 12th, 2023. Registration for APA U opens tomorrow, November 4th. Also, T3 will be in Fort Worth, January 10th through the 12th. As part of the registration, discounts are being provided for the new digital copies of Operations Maintenance and Custodial Guidelines. Registration for the T3 is now open. Professional continuing education credits are being offered for today's program. AIA members who need their attendance reported to AIA should contact me at Billie, B-I-L-L-I-E, at APA.org. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenters. If you're just calling in, make sure to send me an email at billie@apa.org so I can send you a certificate if you would like one. The system only recognizes you if you log in. At this time, it's my pleasure to turn this over to Jonathan Thomas. Jonathan, take it away.
Thank you, Billie. Hello, everybody. Thank you so much for joining us today for our webinar on designing buildings for maintainability. My name is Jonathan Thomas. Please call me John. I'm a professional industrial engineer, certified energy manager, and certified reliability leader. I'm going to go off. We've got a reasonable amount of attendees today, so I'm going to turn off my webcam just to make the presentation smoother. I did want to stay on to kind of say hi to everybody prior to. So I've been in facilities asset management programming since 1998. That entails asset inventory, data collection, preventive maintenance programming, capital planning, FM resource estimation, and benchmarking. I've personally inventoried over 36 million gross square feet of space in both new construction and existing buildings, and a lot of the information that we'll be going over today has come from those endeavors. So BMOC, Building Maintenance Optimization Consultants, we're bottom-up consultants, and we're solving an optimization problem, which is an engineering endeavor where you're trying to get the most value out of constrained inputs. And the inputs to our optimization problem are the workforce, management, physical assets in the building, and the computerized maintenance management system, CMMS, and other software applications. We fill the gap that's been left for a long time in the marketplace in asset management, left by facility condition assessment service providers, commissioning agents and design and construction teams, CMMS implementers and professional services groups, and in-house technical staff. So today we will be going, we will introduce our thesis in context of the asset life cycle, starting with conception, where we'll discuss strategic considerations and specification recommendations, and then the cradle, where we'll talk about installation quality assurance and turnover, and then conclusion, we will talk about turning over into the life and grave components of the asset life cycle. And then we'll have some time for Q&A. So we'll start with designing buildings for maintainability in the asset life cycle. So just to introduce the concept, so construction standards are usually owned by planning, design, and construction. But what we propose is that facilities management should enhance them by submitting maintainability items for consideration. During the course of this presentation, I'm going to be using the terms PD and C as a general term for an in-house design and construction team, and sometimes including the architects, general contractors, and subcontractors. And then FM, I'm going to be using for facilities, which is the entity that's usually charged with taking new construction into its existing asset management program and ensuring that the owner institution is getting the most value out of those assets over the course of its life. So this presentation is not necessarily on the application of reliability engineering techniques and concepts. So concepts like ergonomics, testability, identification, standardization, modularization, simplicity, and accessibility are all very important parts of reliability engineering, and they should be taken into account, all of these things, when something is being designed and implemented. But in the reliability engineering world, this is more focused on when you're replacing an asset or something that's mission critical, like something in a production line or oil and gas or transportation. So this presentation is on turning over buildings such that they have an optimal chance of being maintained properly by FM. So the problem that I've seen almost all of my career is that FM is almost always short on staff, and that's not getting any better in this market. It's very, very hard to get staff and then keep the staff. So huge challenge there. So if a building is too resource intensive to maintain and FM is short on staff, then what happens is these buildings just don't get maintained. I mean, they don't get maintained to the level that they need to be maintained in order to deliver the energy efficiency, the services, what have you, that the design and construction team, PD&C, wanted to deliver. And then there's another issue, just an inherent problem, is the construction budget is not always motivated to affect the maintenance budget. So in many cases, if PD&C is putting in, or the architect and engineer or consulting engineers are installing a new system for a building, whether that system is going to cost double the maintenance costs or not really doesn't really come into their purview, because they're more interested in installation costs versus payback through energy savings. So our thesis: FM needs to engage in enhanced ownership of the early stages of the asset lifecycle. So what is the asset lifecycle? Well, we're going to call conception the planning and design phase. The cradle part of the life cycle would be the installation and acquisition. So in the case of an existing building that facilities is taking over, it would be acquisition. And then we get into the longest part of the life cycle, which is the operation and maintenance portion, whether it be preventive maintenance, predictive maintenance, routine, corrective, compliance-based maintenance. And then finally, all of this needs to be done with the grave in mind. We always hear begin with the end in mind. Sage advice. It's in effect here as well. So what do I mean by enhanced ownership? So during the design phase, our recommendation is that staff and budget estimates based on the actual components of the design of the building be developed. So facilities can get an idea of the resources that are going to be required to maintain and operate the building. Then they need to determine if a particular technology is feasible and it's going to be able to operate and deliver the design service for an acceptable period of time, namely the full projected life cycle of that system. And then we believe that facilities should have an impact on whether a design alternative is accepted or not. So we're not saying that they should just drive the bus fully and have autonomy there. We're just saying that they need to have a significant voice in the decision. And sure, we're talking about new construction today, but these concepts can apply to renovations and energy efficiency upgrades as well. If there's going to be an energy conservation opportunity that's explored, multiple options will be taken a look at. We just think facilities is going to be the authority when it comes to determining the resources required to maintain the option long term. And ultimately, BMOC, we've put together a few presentations, and all of them are designed to bridge the gap between PD&C and FM, so that asset management truck can get across the bridge. So now we'll talk about some things that can be done during the conception portion of the asset lifecycle. So here's some basics. So construction standards should already treat product quality, value engineering, and installation concepts. We're not, during this presentation, I'm not seeking to redefine or reframe construction standards in general. Much of the information is outside of facilities realm and very much in PD&C's realm, and they do it very well in general. But some of these concepts do have an impact on maintainability, so they should at least be reviewed and understood by FM if they already exist. So lifespan and reliability. So ultimately, there should be some verbiage indicating that this matters, the lifespan and reliability of a particular option over another. VE items must satisfy design specifications and is not simply an elimination of service. Sometimes you can remove something that would impact the maintenance of another asset. Or you might have something that's like a structure or something that's supposed to help with maintaining the asset, and it's just flat out removed. These things should be considered very carefully prior to doing so. And then obviously, assets should be installed with proper clearance with structures for maintenance. So proper clearance, and if it's a system that's suspended, the maintenance staff needs to be able to maintain it safely and as rapidly as possible. Now to get into more advanced items, primarily the evaluation of new technologies. So maintenance estimation, when a consulting engineer or somebody who's trying to push a product or system, when they want to have it installed into a building, or maybe code is requiring it, they generally, from what I see, the payback calculations, and I'm a certified energy manager, so I've seen this myself. Maintenance costs are not included in payback calculations. So the assumption is that, in general, you know, in some cases of very experienced engineers, you might see this, but in general, they're just looking at the installation cost, the initial cost, versus payback in terms of energy savings. And they don't take into account any differential in maintenance. So they won't look at alternative A and alternative B and say, well, this is the difference in maintenance costs between the two, so we're going to deduct that from our energy savings calcs. So typically, these systems will get justified based on energy savings, and then facilities is just left to figure out how to maintain it. And this is why, you know, when LEED was really getting a full head of steam back in the 20-aughts, you had a bunch of buildings that were very shortly thereafter reporting that they were not delivering the energy savings that were initially promised. I think a part of it is due to this circumstance. So here's a couple of cautionary tales. These are based on maintenance staffing and budget analyses that we completed after buildings were already constructed. So we went into the building when it was nearly turned over. We collected the asset data, we did plan review, asset inventory maintenance programming, primarily preventive maintenance programming, and then looked at the staff and budget analysis for the new building. So the details of these examples, I just want to qualify. They're presented for your consideration as a concept for the need to analyze the maintenance costs. They are not broad commentary on a particular technology or system. So the systems I go over, I'm not saying that they're bad systems. I just believe that they were poorly executed. And it's possible that these systems were mandated by local authorities, so I'm not intending to besmirch anybody who is in the planning, design, and construction, or even FM side involved with this building. So first, I'm going to go over natural ventilation. This is, in this particular system, there's multiple ways to do this, but when exterior conditions were warranted, louvers opened up to allow fresh air through the ceiling plenum. So at each, going around the building, on two sides of it, you had a plenum that allowed air to come in. And then the exhaust, generally in these systems, is out the other side of the building or through a central core using a chimney effect. And it cuts down, it's sold on the fact that it cuts down on the need for mechanical ventilation when conditions warrant. The alternative to this would be a standard VAV system, which is variable air volume, consists of central station air handling units with filtration there, fans and filtration there, and then variable air volume boxes downstream, which are very low maintenance. All they have are dampers that modulate for airflow, and in some cases they've got reheat coils that will provide booster heat. So in this system we had 61 variable air volume boxes. This was a VAV system, but it was not traditional. You had 61 variable air volume boxes that required filters because they were your first stage of filtration due to outside air coming in. And those filters require replacement quarterly. And even though they're not on all the time, they needed to be replaced quarterly because above that ceiling, you're accumulating dust. That ceiling tile is eroding and producing dust just over time as it breaks down. And you just have air coming up through the seams and everything. So dust is getting up there even if those louvers aren't on. Due to daylighting systems in this building, the ceilings are 16 feet high. That's to the bottom of the drop ceiling structure. And you needed a lift or a large A-frame ladder, even a 14-foot A-frame ladder. It takes up a lot of space when you're setting it up, but required a lift moving through these cube farms. So as another part of the daylighting, you had these low cube farms around the offices that were, and it was, beautiful building. But when you're going and replacing these filters quarterly, it's quite disruptive to the working environment. So we estimated that it represented an 18% increase in the maintenance labor requirement for the whole building over a standard VAV system. So next, rainwater reclamation for gray water. This was another system we observed. It was rainwater's captured in a cistern, and it was utilized as gray water for toilets and in the building. People don't want to use a toilet with green water in it, so they had a reverse osmosis system that was installed to prevent the water from appearing green. The alternative to this would be no water treatment at all and just usage of city water. So this system included RO membranes, filters, and 5 pumps. Would not be needed at all for the alternative system. And it represented a 5% increase in the maintenance labor requirement over the alternative for this particular building. And then also, it just made me think when the payback calculations are calculated, when the initial cost is calculated, are they included? Is it a fully loaded cost that they're considering when they're comparing it to the energy savings? Does the cost include general contractor markup? Does the cost include any design fees? Does it include labor rates for that area and markups? I would assume that they are included, but I would encourage anybody who's a part of that process to take a look at those numbers and ensure that they are included, so you're getting a full understanding of what the initial costs for that system are. So next we'll go on one of my favorites or least favorites to see in a building, water source heat pumps. These are point of use refrigeration systems that are used for heating and cooling within a building. And we still see them all over the place. We still see them today in new buildings, and we see them all over. We see them from the southeast to the Midwest to the West Coast, and they're often suspended above ceilings. We're seeing some that are able to be floor mounted in a machine room, which is good. The alternative system in this case would be a standard VAV system, which would be ideal. But I'm going to compare it to a fan coil unit or a small air handling unit system due to the fact that it's a little bit easier to conceptualize replacing a water source heat pump system with fan coil unit system, just because that piping network is there. So water source heat pumps are high maintenance items with filters, compressors, and sometimes belts. So when I say compressors, these are refrigerant compressors that you're seeing on the screen. It's a little bit blurry of a picture. I apologize for that, but it is a full refrigeration system up there that is cooled with water that goes to a cooling tower typically. The alternative would eliminate piecemeal compressor maintenance and refrigerant management. I mean, so when you're working on these systems, you're above a ceiling with little space to work, on a ladder, on a lift, and having to deal with refrigerant. So these systems, 52% more labor is required to maintain the water source heat pumps over the alternative. And one of the big problems is that the labor costs are 80% more because you now have to have a licensed HVAC technician to deal with that refrigerant. You can't just use a generalist, which would be much cheaper labor. So next we'll talk about some specification recommendations, also in the conception phase. So consider these for addition to your existing construction specifications. Note that they may already be included. So check before requesting. Just as a general rule, I would say assume the best before engaging in requesting modifications. Assume that it's already covered. Go look at any documentation that you can. Go talk to anybody you can to review what already exists, so you're not being redundant and you're not being untrustworthy or demonstrating distrust in any way, shape, or form. So next, on active projects, FM should tour them for quality assurance. Tour the building, and we'll get into that in a minute. So first, a couple of considerations, starting with machine roomless elevators. I've seen traction and hydraulic versions of these. They are unsafe to maintain compared to the alternative. Elevator mechanics that I've spoken with prefer machine rooms, and they groan at the concept when they have to maintain the machine roomless systems. And this is when my clients have an in-house elevator shop, which I know is not always the case, but it will increase the maintenance costs for service contracts as well, because they require double the labor for all maintenance activities due to safety issues. You have to have one mechanic there working on the equipment and then another one ensuring safety. It basically just doubles the time. Next, fans. And this is a good thing. We're starting to see more and more direct drive fans. We recommend that they be utilized when possible. Direct drive fans require 50% less labor than a belt drive fan. So 50% less labor than a belt drive fan. Which means, and this is due to the actual preventive maintenance steps are about half of what is required for a belt drive fan, but also you only have to do PM on direct drive fans semi-annually, whereas for a belt drive fan you have to do it quarterly, or it's recommended that it be done quarterly. A lot of organizations don't even have the resources to do proper maintenance on belt-driven fans. So due to the fewer work orders required, you have less planning and scheduling to worry about. Also, you don't have as many parts, you don't have to buy belts, and you don't necessarily need special equipment like laser aligners. Next thing that has been great to see, we're seeing some motors that are permanently lubricated. That's also very helpful and reduces the maintenance. So when that can happen, specify permanently lubricated motors. Next, access panels. Ensure, so for exterior equipment, when you've got a strobic fan, or high plume dilution fan, or a fan on a stack, just a utility set, primarily utility sets, but and then also on basically the mushroom style fans. There's a lot of these types of fans on in new construction, even still to today. Specify equipment that has easy access to them. So basically clips that you can unclip, and then but are very strong. Allows you to open the top on the mushroom style fans. On utility set fans, access panels with hinges are way better than just big heavy shrouds where you have to take off the whole thing, where you might have multiple people up there, and you might accidentally puncture a roof when you pick up a big heavy shroud off a utility set fan and then lay it onto an EPDM roof or something like that. You could puncture it. Next, rust-resistant fasteners on exterior fans. I can't tell you how many times we've gone up to work on a fan and just coughed on one of the bolts and it sheared off. So rust-resistant fasteners are highly recommended. Next, we're going to talk a little bit about fan coil units and cabinet unit heaters, and really any equipment that seems very benign and not worth anyone's time to think about. But when you have these systems, you've got 40 to 400 of these in the building, and that maintenance time compounds big time. So going around and getting all these fan coil units and replacing the filters in them quarterly, which is when it should be done, is because usually the filters are at the bottom and they're getting all that dust from the floor. They're basically like a vacuum cleaner. So these really need to be replaced quarterly. They're not usually replaced quarterly. They're usually replaced semi-annually because of resource requirements. But so when these systems are installed, we recommend that the best ones have durable coated enclosures. Makes for easier access, and it reduces the chance for the panel to get warped, the panel that you have to remove to get to the filter and the motor. Recommend units with hinges as opposed to sliders. In many cases, these systems can have a little slider panel that you lift it up and then push it down. You have to line up all the tabs with little slots and push it down. And on these units can be floor mounted, which is a little bit easier to work on, but they can also be flush mounted onto a ceiling. So if you have a heavy panel to pull off one of these fan coil units, it can be just a real bear to deal with when you're taking it down. Also, it can be unsafe because it can just fall while you're removing it. And obviously there are steps to be taken that can avoid that, but we recommend hinges on these units where possible. Also, when these are durable, high quality units, they tend to look better for longer. They dent less easily, or it's more difficult to dent them, I should say. And again, the warping on the panel is less frequent. We've seen these units with quarter turn 6-point security fasteners. It makes it super easy to get up there and just put in your screwdriver with the bit, quarter turn on 2, lift it down with the hinge, and you're changing that filter. You're in and out of there in 2 minutes. So here's so on the left, I'm showing one of a unit with a slider panel, and then just over time, it can get to look like the one on the right. I do not have a picture of the actual panel, but it was, I assure you, all bent up and dented and paint chipped. So next, I'm going to talk about being judicious about placing above ceiling assets. And I know some of you might be saying, "Oh, come on, maintenance just needs to learn how to maintain this stuff. It's their job." And yes, I agree. They will learn how to do it, and they will find a way. I'm just trying to come up with systems under which the organization can succeed rather than just using motivational techniques. Okay, so minimize equipment with belts, filters, grease, and refrigerant above a ceiling. Just period. When you can do it, do it. Put it in a mechanical room, put it on the floor where it's easy to maintain. In that mechanical room, don't put too much stuff in it. Ensure there are clearances. I've seen mechanical rooms where they had very little space and everything was just piled on top of itself and nothing had any clearance. So watch for that as well. But back to the above ceiling equipment, if a unit is above a drop ceiling, then install it as close to the ceiling as possible, while also allowing for access and the tile removal. The unit that you're looking here, okay, so also consider the usage of the space below and the frequency of required maintenance. So the unit that you see here in the picture, this was a particular bugaboo. It was above a gym. It's an exhaust fan, belt driven, and it was very large. And this was a 2018 building. So this was something that was recently installed. So in order to maintain this unit, you had to pop the ceiling tile, but then there's a good 6-foot clearance between the ceiling tile structure, or the drop ceiling structure, and the concrete structure above. And this was, actually it may have been 8 foot. It was a lot of space. I was on a 14-foot ladder and I could barely reach the bottom of this unit. And I had to be up through the ceiling tile. The ceiling frame was like at my mid thigh, and I still could only reach the bottom of it. So to work on this unit, you can't do it on a ladder. Everything's too heavy. All those nuts that you see on there are 3/4 inch or so, maybe 1/2 inch. I'm sorry, not 3/4 inch, but 1/2 inch. And you have to have heavy equipment to take them off. There's a belt in there. You have to do this quarterly. And furthermore, you have to remove the ceiling tile structure to get to it. You have to take out the grid, not for the whole room, but part of the grid would have to be taken out to maintain this unit. And that's quarterly because it's got a belt. So this one was tough to see. Next, minimize the installation of assets in places that will require access to restricted spaces or risky spaces, I should say, like intensive research or teaching spaces, offices of sensitive staff. I mean, this is knowledge that FM can bring. I mean, in-house PD&C can bring it as well, but FM sometimes needs to bring it up as well. Like when you have the university president's office, try to keep maintainable equipment out of their office. Commercial kitchens, they're always very busy. It's difficult to coordinate maintenance in there. So when you can, have centralized refrigeration systems that are in a mechanical room that are out of the way, maybe accessed from the outside rather than having to go through the commercial kitchen space to do the maintenance. And also especially avoid above ceiling equipment. And sometimes you see these dishwasher fans that are in line and then they're above the ceiling, actually in the dishwasher space. Next, dorm rooms. Avoid going into dorm rooms wherever you can. One of the best systems I've been seeing, traditionally you'd have fan coil units, a 4-pipe fan coil unit system with 1 or 2 fan coil units in all the rooms. What happens there is I almost always see residential and dining services, again, another general term I'll use. I almost always see that they replace these the filters in those units semi-annually rather than quarterly when students aren't in the space, but they really do need to be replaced quarterly. And it's difficult to do it mid-term when the students are in the space. So one of the best systems I've been seeing as of late is dorms with the suite style, and they will have an upright air handling unit that's accessed from a utility closet in the corridor, so they don't have to go inside the dorm room. Even better, I've seen these systems with central chillers and boilers and chilled and hot water rather than refrigeration systems, but that's another note. But having a system like that that's accessed from the corridor rather than having to go into the room is ideal. Next, avoid installing any equipment in women's restrooms, bathrooms, and locker rooms. 88% of the maintenance staff are male, and it's just less risky. It cuts down on risk to have systems like inline fans that are above the ceiling or fire dampers. It's best to have those outside those spaces. They're much easier to coordinate and much less risk there. Now we'll talk about the cradle, installation quality assurance. And this is something that everyone here is probably going to be pretty familiar with and probably does, but I do want to identify this as a concept for completeness. So one, have your staff, a consultant or a subcontractor, survey assets for maintainability beyond code requirements. So that's one of the things BMOC does when we're doing our asset investiture for new construction. We have an opportunity to identify maintainability issues when we're out there, and we do highlight those to our clients. One of those was, in particular, I had an air handling unit. I was inventorying and opened the tried to open the access panel for the motor, and it was on a hinge, and there was about a 3-inch clearance between that door and the wall, the concrete wall next to it. So I don't know what they did with it, but we did highlight it to our client. They needed to move that door to the other side, or come up with, or add a door on the other side of the unit. Do maintenance platforms, hatches, access devices like ports or tubes or maintenance tubes, or ladders, or fixed ladders with safety cages in some cases, well, they need to be installed for safe access. Like in the case of the fan that I showed that was several feet above the ceiling tile, I think it's feasible. You should at least check the feasibility of installing a steel maintenance platform in front of it that has a ladder that goes down to the top of the ceiling tile grid, where you can get a lift up there and then climb the fixed ladder the rest of the way, and then have a large enough platform to maintain the unit. They would have had the space. There was a good amount of clearance in front of that unit, so that might have been an opportunity there that maintenance would have seen. Next, this is one of my favorites. So sprinkler systems are typically checked later in the project after all the equipment has been installed, and sometimes they will have to move sprinkler heads. In many cases, they have to move them. And we've seen it before where those sprinkler heads get moved right in front of a fan coil unit where you cannot open that hatch at all. And it was one of those facepalm moments that I had. It was pretty funny though, I have to admit. So watch for things like that, even towards the very end of construction. Just be prepared. Like when that building gets turned over, make sure the subcontractors or the general contractor is still on the hook to be able to make late fixes like that. Next one, air handling units installed above conduit and piping. I've got a particular image in my mind of a unit that was about 4 feet above the ceiling grid, and it was a narrow hallway. It was like a utility corridor in a research lab, and popped the ceiling tile, and it was 100% obstructed. Well, let's say 95% obstructed by utility piping, IT raceway, and anything else you can think of. Sprinkler pipe. I remember we couldn't find the unit. We searched all over the place for it. We had already looked above the ceiling for it, and then we finally found it. We had to open the correct ceiling tile, and there was about a 1/4 inch space between piping that we were able to see and identify that unit up there. No way that unit's getting maintained. And then lastly, and this is one I hear of frequently from people, lighting systems. You get these specialty lighting systems in buildings. Can they be maintained? Is there a way to lower those systems down to the floor level where you're able to then go around and change the light bulbs? You get these big fancy light fixtures, and then you can't change the lights in them. They start to look terrible when some of the lights are out. It's like someone smiling with missing teeth. But that seems to be a big, a frequent occurrence in these projects. So at turnover, other things to consider during the project while everything's getting installed. Is the building ready for maintenance at turnover or before? Is commissioning sufficiently concluded? If not, is there a timeline for conclusion? Our position is that FM should be in the know in this process, because it affects that handoff from maintenance to maintenance during the construction to their maintenance. If you have equipment under warranty, so does FM have the knowledge about adjustments made during commissioning? And is there a policy on tracking maintenance prior to turnover or prior to facilities taking over the building? Because what will happen is a lot of work that needs to be tracked to the maintenance histories on asset records in the CMMS will occur during either the commissioning phase or maybe the last 3 months of construction, into commissioning, and then into the warranty period. But that information needs to be tracked to the asset record. If it isn't, you have a big gap in your understanding of that asset's performance over time and its maintenance needs. So highly recommend if contractors taking over maintenance for a year, that they track the maintenance as a part of your system, which should be set up prior to that building being turned over. So on that note, so we're going to conclude with talking about turning over to the life portion of the asset life cycle and planning for the grave, all at the beginning. So designing buildings for maintainability, it's an asset management programming endeavor. So if you don't use the terminology asset management programming, maybe consider researching it and taking a look at some of the standards that are available on the worldwide, really, on the topic. So conception of the asset management program should begin with the cradle, life, and grave in mind. So anything that's designed for installation should consider all parts of the asset life cycle and their costs. FM needs to take ownership in this process because they're going to have the best knowledge base to apply here and wisdom that PD&C may not have. But to do so, FM must gain credibility with PD&C, and that can be a big challenge. And ultimately, what we see when we're kind of acting as the middle person in these discussions, PD&C wants to help. They're highly capable. They've got a lot of technologies that have been developed in their field. They have a lot of capability, and ultimately they want to help. But the problem is they usually just have a different lexicon or vocabulary, a different focus for the building, and a different strategy, both just strategically and financially. So one item I'd like to bring up is integrated project delivery. I don't know if many on this call have heard of it, IPD, but I've seen it successfully executed on one of my clients' campuses. And I say it's successful because they've continued with the process over multiple projects now. I believe it's a big culture shock. It requires a big change in perspective, but it seems to be a very effective way to get building stakeholders, program stakeholders, the PD&C, the general contractor, subcontractors, architects, and FM on the same page proactively on these projects. So another aspect that we like to discuss as a method for bridging the gap between PD&C and facilities on asset management programming is the turnover work group, which we'll be presenting on coming up here soon. But it's basically a concept to do the IPD without having an IPD project. So you get the program stakeholders, you get FM, PD&C, all in a room to talk about FM concerns. It's not a redundant group with commissioning meetings or anything like that. These are strictly on the operations and maintenance of the building, includes maintenance, custodial, and grounds, and waste management, and topics like that, and user and the user friendliness of the building, etc. Because ultimately the building life cycle is 50 to 60 years, and sometimes even longer. And the design and construction phase is only about 4 to 5. So next, getting prepared to maintain the building. Is the correct asset data collected for population into the CMMS or IWMS or EAMS or ERP or any other string of letters you want to put together? Is the asset data loaded into your CMMS prior to turnover or before? Is it on time? Are you able to start tracking that maintenance? Is your PM program best practice, or is it OEM recommendations? OEM recommendations are only valuable typically in the case of highly specialized equipment. In other cases, your best practices are the best approach. Are your assets in the PM program developed in context with your portfolio, or are you getting some other mishmash of naming conventions and groupings and types and attributes from the general contractor or architect? Are your capital renewal projections integrated into your current renewal plan as a part of the project? And then lastly, if all these things are happening, did you overpay for this service or process? And that's it. We've got some time, right on 45 minutes. Amazing. So thank you so much for your patience, and we can have some Q&A.
All right, thank you, Jonathan. Well, we have questions for you, so let's get started here real quick. Since PDC is not incentivized to add or revise scope for maintainability, what have you seen has been a successful strategy to be more maintenance conscious, or at least not make things worse with value engineering proposals during construction?
So I touched on that a little bit. IPD is what I've seen that seems to work, and I can most likely connect you with people that have been involved with that, so they can speak about it firsthand. But I would say that it just requires a culture and policy change, which is can be a political issue. But I think it needs to be appreciated as something that is going to require some sort of quantitative demonstration of the value to the organization to have a low maintenance system installed versus a high maintenance system. So I think it has to be, just like any change management program, it's got to have executive sponsorship. So I think the higher up you can make this case successfully and use numbers in doing so, I think you start there and then take the execution of the process step by step.
Okay, thank you. Our next question is, we have filters guaranteed to last specified periods of time, but once a building is handed over, they get thrown out at the normal standard period. Any good way to be proactive on this?
Sure. So I would just say that you've got to have the PM program written such that it accounts for that. So you could have an organizational policy on filter changes that dictate which filters are. I've got clients that go and install high efficiency filters, and they just have an organizational policy that filters over a certain size are only replaced semi-annually or sometimes annually if they're a final filter. So I would just say that it's all about how the preventive maintenance program is developed and executed in the CMMS.
Okay. Our next question is, why don't commissioning agents comment on maintainability during design?
It's not their field of expertise. That, in short, I think that's a very simple response to that question. I think that's the problem with almost all. So that's what I meant when I said PD&C has a different vocabulary. You say data, they say data. The two things, FM says data, PD&C says data. The two things are very different, because PD&C is very concerned with material acquisition and tracking of that and logistics. FM doesn't care about that. They care about what's in the building and what its mechanical configuration is, such that they can design their maintenance program and execute. Same thing in this particular case. When PD&C is looking in all parts of that side of the fence, so that includes commissioning agents, architects, engineers. When they're looking at it, they're thinking about it in terms of initial cost, acquisition, and installation. They have to have someone else point out to them the maintenance impact. And I just don't think, again, I've seen this consistently for, I'm not saying I have the longest career, but 25 years. I've seen the results of this kind of taking for granted that everybody understands maintenance. It just doesn't happen. And I think that's one of the big problems. So we just need to understand that some organizations have that knowledge with authority and others just do not.
Hey, John?
Yes.
Hey, John? This is Doug Litweiler, one of John's esteemed colleagues at BMOC, and I need to interject here. This is really a hot button issue for me, and this is a great question. My words of advice for folks in the on the O&M team is to never ever assume that the design and construction and commissioning team know more about maintenance and operations than you do, because they don't. That's not their forte. That's not what they've been hired to do. And the default position is typically to delegate the responsibility to the design and construction team and the commissioning agent, delegate to them the need to look out for the O&M team. It never happens. It never will. That's why I urge my friends in the operations and maintenance groups to really take the bull by the horns and absorb some responsibility early in the project, even into the design phase, to really drive the design and building turnover to facilitate maintenance and operations. John, could you go back to that slide that shows the timeline for a project real quick?
Yes, and then I would like to make a distinction.
I want to just emphasize this, and everybody needs to understand this, and I'm really speaking to the design and construction team, well, and the O&M team, is that the design and construction phase of a building is so short compared to the life of the building that it's absolutely imperative that everybody on the team understands the importance of designing the building and turning it over to support operations. To focus on that 1 to 4 year time at the beginning of the building and say that's the most important part of the building, and not so. You really need to focus on making sure that the building is ready for maintenance and operations going forward. So, John?
Yeah, and I just want to throw in another distinction. So we use the term M&O an awful lot, maintenance and operations, almost as if they're the same thing. But they're not. They're two different things. And I would say that the distinction I would draw, like a commissioning agent, they know operation very well. That's their whole job, to make sure the building operates according to design and can be modulated accordingly. So they do know operations. They don't know maintenance. And the example I give there is if you ask a commissioning agent if they know what a CMMS is or what's required to generate work orders, they generally aren't going to have that expertise on staff. So they know the BAS, they do not know the CMMS.
And the folks on the line here, I would suggest you might want to take a screenshot of this slide and keep it away somewhere and play it at some point in the future to show your design and construction team that this is really what it's all about. It's not about the design and construction. It's about the life of the building and the need to maintain it. So I would suggest you go ahead and take a screenshot and keep this handy. Just remind everybody that how important it is to focus on the operations aspect, the maintenance aspect of a building. Back to you, John.
Thank you. Billy?
Okay, our next question then is, when IPD is used, everyone, including the owner, agrees to participate in the cost of any errors. Does that mean the FM organization pays for something it missed, or does it remain PD&C's responsibility to handle?
I cannot speak to something like that. I'm sure it would vary from project to project, and it depends on how it's executed. Because I guess it's all about risk, right, and managing risk during the project. So I think it just depends on how it's set up.
Okay, thank you. Next is, what other learning tools would you suggest for new facility professionals looking for more technical knowledge? especially related to common facilities related issues with certain types of equipment?
Well, new facilities professionals, I would assume is middle management or higher. So I would say shadow your maintenance staff. Go and learn about what they're doing most of their maintenance on. I think that's the best way to do it, because you see that many of these mechanical systems that are in buildings are, it's not like you have tons and tons of them. There's some main systems that you need to maintain that are installed in a particular configuration. So seeing what they have to do in these buildings, and maybe look at, if you have it, look at some data on your buildings in your CMMS, export maintenance histories, and see if you've got, see which buildings of yours are costing more per square foot than other buildings per square foot. And then go out and tour those buildings and figure out why, and ask the maintenance staff why that might be. Outside of that, there are reliability engineering sites like Plan Engineering Magazine. There's Reliability Web, and they have a lot of articles, and they've got a lot of publications on maintenance concerns. What are some other ones there? Any come up to the top of your head?
Not right now, not that I'm aware of.
So basically, I know you're an avid reader of Plan Engineering, right?
Oh yeah. There are lots of periodicals and resources that are available to help organizations and individuals address these issues.
Yeah, and you can get certified. So I'm a certified reliability leader, and I think there's a couple of outfits that do it. And you can look into that as well, and then start on a path in reliability management, which is an excellent way to develop that skill set.
Okay.
Hey, Billy, are there a lot more questions left?
We have a few more to go.
All right.
So, is it correct to assume, as part of project closeout, we need maintenance documents from time of startup?
That would be my recommendation, absolutely. Because I think if you don't get the maintenance histories against your asset records in your CMMS, you have a big gap. So I would say not only at project turnover, but you need to have language written such that the whoever is doing the warranty work is either, you have some sort of workflow to get that information into your CMMS, whether it be them doing it directly or them submitting the information to your work control staff so they can add it.
Okay, well, we just have a couple of more, not really questions, but comments. So I'm going to read these to you. Doug's comments are timely and applicable to the custodial team too. We never get terrazzo floors turnkey and always have to lay the final sealer on terrazzo floors.
Oh my.
And
yeah, that's a great comment. Thank you.
And we have one here. As a female tradesperson, I think rather than avoiding women's rooms because most service people are male, maybe we should be recruiting more female techs and service people in FM. I've had to enter men's rooms for service on many occasions.
Understood. Yes, absolutely.
Okay, and
Billy, I'd like to throw one comment here before we close out. One of the things I think would be a really great idea, and I've really never seen this done, is sometime maybe a year following the turnover of a building, I think it would be really great to have a meeting with the members of the original design team, members of the construction team, and members of the FM maintenance team. Get them in the same room and have them do a full debrief and post-mortem of that project. By assuming that's been in operation for a year, some of the shortcomings probably will have surfaced by then. And the goal being is to identify what went wrong and what you can do better the next time. but I've never ever seen an organization establish this debrief of all of the stakeholders a year in after the building has been turned over. But I think the goal is for all the team members to get better and better for the next project. And I think that's something everybody might want to consider trying. And if it doesn't work, well, at least to give it a shot. But consider asking the team to get together a year following the turnover and just talk about what went well, what didn't go well, and what you can do better next time.
Okay, well, that's going to end our time allotted for today. So, Jonathan and Doug, thank you so much for the presentation. And to our attendees, the presentation will be available starting tomorrow. So just send me an email and I will send it out to everyone. It'll also be in your follow-up email. So, gentlemen, thank you so much. And to our attendees, thank you for taking time out of your busy schedules to be with us today. We have one more webinar for the 2022 season next week. So until then, be safe, stay healthy, and be kind to one another. Thank you so much. Bye-bye. Have a great day.
And thanks everyone for this opportunity. It was wonderful. Thank you. And fun.